For this week, this is a set of vocabulary we worked on for this week. And at the end of class yesterday, the beginning of class today, we started working on this activity. So what we're going to do is we're going to go over these vocab words for geologic time. And at the same time, we're going to talk about how those fit into this activity. So let's take a quick look first at the first questions for this. The first question, if you just jump down to the analyze and conclude question, says, what fossil clues in layer A and B indicate the kind of environment that existed? And I also put the word depositional environment there on that question, because that's really what they're asking, is what is the depositional environment that occurred when you see these fossils? So let's talk about what you had for the answers for question 1. Okay, so it says what fossil clues, and of course we see a fish and a shell and a trilobite that we don't really know what they are. So that tells us that obviously there was a water environment when this formed. And if you knew a lot about the fish, you might be able to say if it was salt water or shallow water or something like that. A couple people yesterday said shallow water because the textbook points out that that's where fossils are most likely to form. Okay, so then number 2 says, which layer is the oldest, and how do you know? Who had a good answer for that? Yes, layer A, because? Excellent. And how do we know, what did we talk about yesterday as one of our vocab words, how do we know that the lowest layers are the oldest? Because the book said so. Yes. And we call that the law of? So the law of superposition, and this is going to be one of those, to me it's a very obvious thing, but it's like uniformitarianism and some of those other things, in that it seems so incredibly obvious, but we need to all agree on it, and then we can always say, oh yeah, the lowest layer is the oldest, because it is. So the law of superposition is that in undisturbed igneous rock, undisturbed sedimentary rock, the lower layers are older than, and the younger layers are on top. And again, that seems quite obvious because that's how it forms. The lower layers form, and then other ones come on top of it. Another key part of that we were looking at on one of the other questions is it has to be undisturbed sedimentary rock. So if there's some sort of earthquake or plate tectonics or folding or that kind of stuff, or an unconformity, which we'll talk about, that might change it. But so that is the answer to number 2, that these lowest layers are going to be the oldest. And then how do we know that this layer A was older than layer W? How do you know that? Because why? It has more layers, but there's a better reason other than just more layers. Simpler life forms, maybe. How else do we know? How do you know that, well, which layer does W match up with over here? B, right? So what you should be able to tell, and in the textbook, of course, it's much easier than on your paper where it's black and white, because they give you colors, like the layer is pink. But what you should see is that this has the fish, the shell, and the other shell, the same as this one. And so this should be the same age as this because it's the same type of rock. Of course, in real life, it's a little more complicated than that, but so then we know that this one is there. And so it's either deeper or was destroyed or whatever. But we can guess that B is the same age as W. Okay? Yes. Okay, so the question is that just that there's, why are there only, 4 layers here, and there's what here? 3, 6, 7. And we don't really know. The picture here kind of implies that it's like 2 opposite sides of a canyon, but all it says is Site 1 and Site 2. So they could be just two different places in, I don't know, the state of Colorado, and you're looking at the fossils. So they don't really give us that information. So what we have to do is match up the fossils. And in real life, scientists do actually do something very similar to this, and they say, oh, well, here we had, something that was clearly underwater, followed by, what does this funny diagonal line mean? Lava. So there's some sort of volcanic eruption. And so we see this pattern that this was followed by this. This was followed by this. So the scientists say those appear to be the same layers. And then exactly, as you pointed out, then we actually seem to be missing some layers here. And we'll talk about that because that's question 7. So let's hold on to that question for a minute. Okay, so let's look at the next question. Question number 3. Which layers formed most recently? How do you know? So that's easy, right? Because that's exact same. Which layers are the newest? Which layers are the newest? Z and G. So this one's the youngest, as is this one. And again, we can say we know that because of the law of superposition, because the younger layers are on top, because we agree to that. Now, do you think G and Z are the same age? Or is G younger because it's higher up? What do you think? Yeah, I think they're implying by making them both orange that they are the same age. Because if you look at the fossils, what do we have? A jawbone, a leaf, and a feather. And over here we have the jawbone and the feather and the leaf. So I think that what they're trying to tell us is that they are the same. It's kind of hard to tell on this image, but I think it's supposed to be the same. So that is what they are hinting, that that's what that is. Okay? That makes sense? And then we kind of already hinted at this. Why are there no fossils in layers C and E? Because? Because it's lava. Yes. So there's no fossils because it's lava, right? And so if there was a big eruption, whether it says it's lava, so it was lava that covered the surface. So obviously that's just going to incinerate anything in the path. In its path, fossils are not going to form. It's actually really tricky because it could be that this, of course, is kind of this beautiful ideal situation. We got tons of fossils in every layer. And in real life, of course, there's not that many fossils. But you wouldn't have any in igneous. And what kind of fossils occurred in layer F? That's pretty easy. You can just read off the chart, right? Dinosaurs. What other picture do we have? Birds and plants. Okay. All right. Then we go to Site 2. And again, this is just exactly what we've been doing here. Which layer at Site 1 might have formed at the same time as layer W? So I think we already matched that up, right? We just went over that. Should be layer B because they have the same fossils. Okay? Questions about that? Piece of cake? Now, the tricky one. Number 7, what clues show an unconformity or gap in the horizontal rock layers? What layers are missing and what might have happened? So yeah, that's 3 questions in one. So let's jump over to, let's see, we'll get back to that. Unconformity. And so an unconformity is a gap in the fossil record where layers are either missing or possibly they never formed at all. So unconformity, I think it's kind of an annoying word, but basically saying it doesn't conform, it doesn't match. And so it's not necessarily going to follow the rules of superposition because something has disturbed it. So a gap in the geologic record, layers are missing, and they could have either been eroded away or they never formed. So when we look back at this picture, so which layers are missing? if we look at this and just match up, and again, it's so nice because they're color coded. So there's pink, and then in the textbook, this one's actually kind of more purple. Then layer E and layer D, and I talked to most of your table groups about this, seem to be totally missing from that site. And then there's the brown one, layer F is layer Y, and those match. So layers E and D are missing. And so you could say that seems to be an unconformity at site 2. So that's the first part of the question. What clues show an unconformity or gap in the horizontal rock layers? Well, those 2 layers are missing. Why might that be? So those 2 are missing. So it could be either they eroded away or maybe they never formed. This, as you just pointed out, E is actually a lava flow. So maybe the lava flow didn't reach this location. Again, we have no idea if this is a hill nearby or if it's miles away. And the same thing, layer D, we don't know. It's got footprints in it. So what do you think that layer might be made of? It has footprints that were preserved. Something stepped in it and left footprints, so it might be. What's the layer like? What's the rock like? Mud. Okay, so this could be a muddy layer. So, I mean, thinking about 2 months ago, what if there was a flood of some sort and a layer of mud was deposited over here? That could happen. So anyways, either they were destroyed, they eroded away, or maybe there's a flood and it just wiped it out over here and not over there. Could have been melted or destroyed. It could have been wiped out by, I don't know, a different lava flow or something. Okay. All right, everybody got that? Piece of cake. Now I am going to erase this scribbliness because next we have another really important question that people always get wrong. Part of the reason I'm spending a lot of time on this, I like this question because you can tell a lot of things and kind of practical applications of all these words. You will see questions like this. There's definitely a question like this on the unit test. Okay? Now here's another tricky question. It says, which is older, intrusion V or layer Y, and how do you know? So which is older, V, which is an igneous intrusion, so part of what you need to know is what exactly that means, how it formed, or layer W. Which one's older? Yes. Wait, which one? Oh, so it's asking which is older, V or Y? Okay. Excellent. So which one's older? Layer Y is older. And how do you know it has to be older? Yeah. So an igneous intrusion, what this is lava coming up, or magma rather, because it's underground, right? Magma coming up through a weak spot or a crack. And so what happened is these layers were already formed there, and there was some sort of volcanic activity underneath, and the magma cut up through it, right? If V was older, that would mean the lava came up and just made a little thing up in the air and just cooled in a magical tower, right? But a lot of people get this wrong because they go, oh, law of superposition, this one's lower, so it's older. But the law of superposition doesn't apply here, right? Because this is not. Why can't we use the law of superposition? Yeah, it's not, you're talking about an igneous layer. And so the igneous layer disturbed the sedimentary rock. Okay? Everybody good with that? I promise you'll see that question again. Okay, and then finally, look at number 9, and I'm not going to go over the whole thing, but a couple bullet points saying how the environment changed over time, starting with the earliest layer, describe the types of organisms, their environment, and how the environment changed. And so you can just, it says the original thing said write a journal. I think that's a little bit crazy, but this would also make a good test or quiz question. So, you could certainly talk about, again, we said this was water. Then you can talk about, so you say, well, there's fish fossils and shell fossils. So maybe it was a shallow inland sea. I don't know, make it up and say what was probably there. Then there was a lava flow. or then the climate changed, or so make us, using the evidence that's here, make a plausible explanation of what happened. Make sense? No problem? All right, let's take a quick look at the rest of our words. So fossil, we have talked about that a couple of times, but I'll put this here so if you want to watch the flipped lesson, you can double check your definitions. So fossil, preserved remains or traces of living things, for example, bones, plants, leaves, nests, or even poop, which are called coprolites. Coprolites are called that because there was these two scientists who were competing and sabotaging each other's data and all sorts of stuff. And the one guy's name was Cope. The other guy discovered the coprolites, and so he named the fossilized poop after his rival. Scientists always have a good sense of humor. Okay, now these two, relative age and absolute age. Did you guys get those defined? Yes? No? Okay. What's the difference between relative age and absolute age? Yes. Perfect. Right. Okay. So relative age is just comparing it to other layers. It's not an exact number. If you looked at this, you could say, what is the relative age of layer D? You can say layer D is younger than layer C. Layer D is younger than layer X, but older than layer Z. Right? So that kind of puts it in context. Somebody at the beginning of class said trilobites. When did trilobites exist? Well, you can actually, there's a pretty good fossil record of trilobites that they were in the early Paleozoic, so you could say they're however many 100 million years ago. And the relative age of layer C, this lava flow, is that it happened more recently than that. Okay? Then absolute age is when you actually find a date for it. And so one of the other sections that I think we did not read yet talks about radioactive dating, things like that. So you're actually calculating, you're using the atomic structure in that to find out how old it is. Okay? No problem? And then finally, so we did unconformity. An index fossil, and index fossils are very interesting because what it is, it's a fossil that's very common in a particular time period, but then you don't see it anywhere else. And the trilobites are a good example. The dinosaurs, in fact, are a good example. Different types of dinosaurs, because dinosaurs, we know that dinosaurs went extinct about 65 million years ago. So if you find something in the time of the dinosaurs, if you find fossils that are right next to the T-Rex, you know that they're roughly, you know how old they are because of that fossil tells you something. Okay, so it's important for dating other unknown fossils. All right, and then these two are really less important. We end up not having a ton of time to spend on these, but radioactive decay and half-life, that's just how they actually find how many million years old something is. Okay, and then mass extinction, again, pretty self-explanatory. Everybody knows about the extinction of the dinosaurs. There have actually been many mass extinctions over the history of the Earth, many of which we'll see as we do our activities over the next couple days. But basically, when whole populations of living things die off all at the same time, and that makes a very distinct marker in terms of the time frame. With the dinosaurs, it's pretty clear that there was an asteroid or meteorite that hit the Earth and caused problems. But that we see throughout history, we see evidence of that, and we don't always know exactly what happened. All right, any questions?